All right. Welcome to your first notes video for Unit 7. Unit 7 Notes 1. This is Miss Johnson and I am going to be telling you today about the fundamental counting principle. So let's look at that example at the top. Just a reminder, when we are doing these notes videos, Miss Humbert and I, we're probably not going to be reading the word problems out for you, so it's a good idea for you to either read them before you start watching the video, or you can pause the video as you go and read them over, but it just saves a little time if we don't spend time reading them to you. So you're going to want to read those on your own. So if we look at the question at the top, we're supposed to make a tree diagram based on the sandwich options that we have. We are given two options for bread, wheat and white bread. Wheat and white. From there, we're given, I should maybe move my white down a little bit. From there, we have three choices for the meat. So I'm going to draw three branches off of my first leg, my first branch. Choose turkey, ham, or roast beef. Turkey, ham, roast beef. And after we choose our meat, we're going to choose a cheese, and we have three options for cheese. So there's three branches that come off of each one of the previous stem. And the cheeses are cheddar, American, and provolone, cheddar, American, provolone, cheddar, American, provolone, and so on all the way down. Now, the way we look at a tree diagram and interpret the results is the number of options that we have are in this last branch. The last branch is where we want to look. So I'm going to look at these options and I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 different sandwiches that we can make. There. Okay. A tree diagram is simply a diagram that we use to show the total number of possible outcomes. Okay, and each one of those outcomes is part of the sample space. The sample space is the list of all of the outcomes. So, for example, if I picked wheat bread with turkey and provolone, that's one item in my sample space. And then when I take all of those and collect them all together, that's the event. So everything that's happening is collected together makes up the event. And from there, we can use the fundamental counting principle to also calculate our number of possibilities. Making a tree diagram is not so bad when you only have a couple of choices for each category, but what happens when we get into having 10 or 20 or more choices, then our tree diagram gets really large, and it's not really reasonable for us to be making a tree diagram that big. So instead, we use the fundamental counting principle. The fundamental counting principle says that if one event can occur m ways and another event can occur n ways, then the total number of possible ways for the two events is m times n. So I take the two and I multiply them together. Now, this is assuming that everything that's in the first event is separate from everything that's in the second event. So the two events don't overlap. For example, there's nothing in the bread category that overlaps in the meat category because you can't be a bread and a meat at the same time. So if I go back to my sandwich example, I had, for the bread, I had two options. For the meat, I had three options. And for the cheese, I had three options. If I take those and multiply them together, 2 times 3 is in fact 18. So I get the same result that I got when I made the tree diagram. Let's take a look at an example. The next one says Farmington High School's soccer team has 3 different options for jerseys. There's 2 options for pants, 2 options for shoes. And we're going to use the fundamental counting principle to figure out how many options for uniforms there are total. So for jerseys, there are 3, orange, white, and black. For pants, there are 2. And for shoes, there are 2. So I take those, I multiply them together, and again, it's not possible for something to be a jersey and a pair of pants at the same time, so they're all separate. Same with pants and shoes, and so on and so forth. So if I take those and I multiply them, 3 times 2 is 6, 6 times 2 is 12. I have 12 different uniforms. Okay. Why don't you go ahead and pause the video at this point and see if you can figure out how many options there are in number 3. All right, let's move on to number 4. Counting arrangements. We have president, vice president, treasury, and secretary, and we are supposed to figure out in how many different ways can they arrange themselves at the assembly. They have to all sit together in 4 seats, and we're going to try and arrange them in a certain way. So let's draw out a diagram here. Just draw ourselves a little picture. There's 4 seats that they're going to sit in. Okay? When they walk up to the seats, there's 4 different people that could sit in that first chair. After the first person sits down, then there's only 3 people left that could sit in the second chair. After that person sits down, there's only 2 left there. And the last, there's only 1 person left that could sit there. Now, to figure out how many different ways this could happen, just like the fundamental counting principle, we're going to multiply all these together. 4 times 3 times 2 times 1 gives us 24 different ways. So there's 24 different ways that they can arrange themselves into 4 seats. And that brings us to factorial. When we look at the word factorial, we're looking at n with an exclamation point. That doesn't mean n, like you're really excited about n. What that says, or how we read that, is n factorial. N factorial. What n factorial is the product of all positive integers beginning with n and counting backwards to 1. So for example, if I have 5 factorial, that means I have 5 times 4 times 3 times 2 times 1. And when I take those and I find the product, it's equal to 120. So 5 factorial equals 120. Let's go ahead and find the value of 6 factorial. I have 6 times 5 times 4 times 3 times 2 times 1. And again, when I take them and find the product, I get 720. Why don't you go ahead and pause the video for a second and see if you can find the value of 8 factorial in number 6. Let's move on to number 7. We're trying to see how many different arrangements there are of 10 videos on a shelf, or video games. Mackenzie's arranging 10 video games on a shelf, and we want to figure out how many there will be. So just like our seats question for the student council representatives, there's going to be 10 spots for the video games, and we're going to arrange them from there. So once we have 10 options for the first spot, once we put 1 there, then we only have 9 options for the second spot, 8 for the third, and so on. All the way down to the very last spot when there'll only be 1 option left. So I take all of those and I'm going to multiply them, which again is 10 factorial. When we plug that into our calculator, we should end up with 3,628,800 different ways that we can arrange the video games. Let's take a look at number 8. Now we're looking at Zach and Brody and they're riding roller coasters at an amusement park. The first part asks if they ride each of 12 roller coasters one time, how many different orders can they ride those roller coasters? So just like our previous example, this is going to be 12 factorial because there's 12 options for the first roller coaster. After they ride one, then there's only 11 for the second. After they ride that one, then there's only 10 for the third, and so on, all the way down to 1. So if I plug in 12 factorial into my calculator, I end up with 479,001,600 ways. Big number there. There's lots of different ways that we could ride those roller coasters, lots of different orders. Now part B is a little different. So there's 12 possible roller coasters, but we're only going to ride 8 of them, or Zach and Brody. Zach and Brody are only going to ride 8 of them. So instead of having 12 spaces, they're only going to have 8. But there's still 12 possible roller coasters. So for the first roller coaster that they ride, there's 12 choices. Once they ride that one, there's 11. once they ride that one, then there's only 10, then there would only be 9, then 8, then 7, then 6, then 5. And I'm going to stop there because they're not going to ride the last 4 roller coasters. There's going to be 4 roller coasters in the park that they don't ride. So we don't want to factor those in because they're not going to be ridden. So I'm going to multiply 12 all the way down to 5 and stop there. And when I do that, that's 19,958,400 different ways or orders. So it's a little bit less than in part A because they're not riding those last 4 roller coasters. It's actually a lot less than in part A. All right, so that's the end of our notes for today. Please remember to go back to Schoology and take the Schoology quiz. Go back to Schoology and take the quiz. Have a great night, and we will see you tomorrow.